So when you're doing polynomial long division, it can be helpful to remember how we do regular long division first. So if you have a division problem like 236 divided by 7, you would set up your long division, and this number is called your divisor. That's the number that's being divided by, divided by the divisor. Your bigger number typically is the first one, is called the dividend. So it's always dividend divided by divisor. So you put your divisor on the outside, and hopefully you remember this from previous math classes. So you would go how many times? Well, 7 doesn't go into 2, so you would go to 23. 7 goes into 23 3 times, so you put the 3 up here. 3 times 7, 21. You subtract to get 2. Then once you got your remainder, you bring down that 6. And then you say, how many times does 7 go into 26? And that would be 3 times again. So again, you do 3 times 7 is 21. You subtract, and now your remainder is 5, and you have nothing else to bring down. You might have learned to make like 0.0 and bring down the 0 and do the decimal form. And that's appropriate sometimes, but for the polynomial long division, it's going to be more applicable if we write this in fraction form. Now to write this as a fraction, you would just take your remainder and put it over your divisor, 5 over 7. So then your answer to this problem would be 33 and 5/7. So that's very similar to how we do polynomial long division. So when we do this one, we set it up, we can start out the same way. So it's dividend divided by divisor, and you set it up so your divisor is on the outside, put your dividend on the inside. And one thing you have to watch for when you're doing this, doesn't apply to this problem, but sometimes maybe if your dividend was just 2x to the third minus 5x plus 4, if you have something that you're skipping, like here, well, with the original one we have 3, 2, 1 constant. Notice everything is in order and we have everything. But if we had 2x to the third minus 5x plus 4, notice this one doesn't have an x squared term. So with this one, you would have to rewrite it as 2x to the third plus 0x squared. You'd have to fill that in, and then minus 5x plus 4, because it has to be 3, 2, 1 constant. If it doesn't have a 3, that's fine, but just whatever the degree is, whatever the highest power is, it needs to go down from there. It needs to have one of everything. Alright, so then that's the setup. So now this is how we're going to do this polynomial long division. We got 2 terms in our divisor, so we're going to go 2 terms deep here. And we're going to start by always just looking at our very first term. So we are not starting out like this one, going how many times does 7 go into 23. We're not going to ask how many times does x plus 1 go into 2x to the third plus 2. Don't worry about that. We are just looking at the first terms, which means we're looking at x and we're looking at 2x to the third. And what we're going to do is we're going to say x times what equals 2x to the third. We want to figure out what that would be. So if you think about it, you probably figure out it's going to be 2x squared. That's what's going to give you 2x to the third. So that 2x squared will go up here, just like how we put that first 3 up here. Then from there, now you multiply, and that 2x squared now has to get multiplied by the divisor. If our divisor has 2 terms, like we have here, it's going to get multiplied to each of those. So 2x squared times x gives you 2x to the third. 2x squared times 1 gives you 2x squared. Alright, so now we come to the subtraction part. Just like over here, we had to do 23 minus 21. So 2x to the third minus 2x to the third cancels out and goes away. That'll always happen. Then we have 2x squared minus 2x squared, because we have to subtract both of the terms, minus and minus. And in this case, that happens to cancel out too. We just have, 0x squared here. That won't always cancel for the second one. It did in this case. But that's okay, so we kind of got our number to come down here. Now we bring down this minus 5x. So now we're kind of at the same part where over here we brought down that 6 in 26. And then our next thing was how many times does 7 go into 26. So now with this one, we're back to this little statement over here. We're back to saying x times what equals this first term. Again, just looking at the first terms. X times what equals 0x squared. And yeah, it's really just 0. If we want to kind of keep things lined up and know what places we're in, it would be like 0x, because x times x is x squared. But I mean, it's 0 anyway, so you just put that 0x up here, and then you keep going with it. So 0x times x, okay, 0x squared, 0x times 1 is 0x, which again, I mean, it's just 0. We don't really need to keep the x's attached to it. But okay, so these cancel out when we subtract, and then negative 5x minus 0 is still negative 5x. And then now we bring down the plus 4. And now we're back to saying x times what equals negative 5x. So now it looks like our number is going to be negative 5. So that negative 5 goes up here. Notice how everything is lined up. We got x squares on top of each other, x's on top of each other, constants on top of each other. Now we got this negative 5. We multiply it out. Negative 5 times x, negative 5x. Again, that's going to cancel when we subtract negative 5 times 1, negative 5. And then now we go to the subtraction, and since these guys are already negative here and here, when we're subtracting them, we're making them positive. So these cancel, and then we got 4 plus 5 is 9. So now there's nothing left to bring down, so we just have this remainder of 9. So we're going to do the same thing for this last part of the problem, same thing that we did with this one. We put our remainder over our divisor, 5 over 7. So that one we got 5/7. This one we're putting our remainder 9 over our divisor, x plus 1. And this time we have to put a plus sign in front of it because it's a polynomial. And then so we put 9 over our divisor, x plus 1. And then that's the answer for our long division problem.